So let me give you some other exercise to tell me. I have a statement A, on another side I have a statement B. The possibilities are true and false. And I have a statement A, I have negation of A. And A is true or false. What should be here, here and here, here?
A is true, then A will be also true. Both A are there.
Both. If this is A, this is A, obviously A is true, it must be A is
false.
true, A is false, is false. And what about this?
This is also
Because this is true, this is going to be true.
This is false.
Negation means true becomes false.
False becomes true.
Double negation means false again becomes true. So do you see any connection?
This is reflection like?
Yes. It means these statements are called equivalent statements. A is equivalent to A and A is also equivalent to negation of A. These statements are called equivalent statements. Sometimes they write like this and sometimes like this as well. Means A is equivalent to A or A implies A and on another side A implies A as well. But I think this is not specified. It will be applied when we study implication and double implication. Okay, one thing else. Do you agree this thing? That negation of A and B is equivalent to what? And negation of A or B is equivalent to what? Do you remember De Morgan's law?
Yes.
Negation of A or
A union B whole complement becomes A complement, B complement. Union becomes
intersection.
and intersection becomes
Union.
So you consider this symbol to be complement. I am giving complement to both of these separately. You consider this to be intersection. You take it to union. So this is going to be equivalent to this. But how you prove this thing?
Using truth table.
Yes. It must be done with the help of truth table. Can you tell me what should be the result here? Negation of A,
And
negation of B,
and
here and because this is or this becomes
Convert
and. You can do this with the help of truth table. I think we are done with half of the part. Yes. I am going to extend this table
second.
to some other columns that I will need. Now what you have to do, you have to,
Negation of A and B.
this table will be helpful for the
Second.
second part.
Yes, sir.
First of all, you have to find out the
Negation of A or B.
this thing left hand side, whatever it is. What is left hand side? Negation of A
And B.
and B.
Or B.
Sorry, A or B. So we have A, we have B, we have A or
A
B.
or B.
You tell me the negation of A
or B.
or B. And how to do this? Just invert these things. True becomes
False.
false,
False.
false, true, false, false,
True.
and true. This is the column for left hand side.
Yes, sir.
Okay. If you get the same thing for the right hand side, then we can say that these two statements are equivalent. Now the thing is that how to find out such a thing for this.
Three.
The first thing is that you need negation of A,
A.
then you need negation of B,
B.
then you will take their and.
And.
So let me find out negation of A.
A.
So
Three column requires.
negation of A,
False.
and it comes from A.
Original.
You know very well, whenever you have negation, you have to just invert these. This true becomes
False. False.
true, false,
True.
false, true, false, true.
Two.
Now negation of B.
B.
It comes from
B.
B.
Original.
This is true, this is
False.
false,
True.
true,
False.
false, false,
True.
Now what you have to do,
And.
you have to take their
And.
And.
and. And whenever you are doing this, and, then you have to find two statements which are true and write true.
True.
Remaining are false.
False.
Is this column equivalent to this?
Yes.
If it is, then statements are equivalent.
Yes.
You can see in these two columns, false, false, false,
True.
and true. So these two statements are going to be equivalent statements. What is the example?
I am a man.
Okay, I think let's take one example. I am going to attend wedding ceremony, or my brother is going. Okay,
Okay.
it means A means I am going,
Yes, sir.
or B means my brother is going.
Okay.
Let's assume this sentence to be true.
Okay.
It means I assure you that I will come to your wedding ceremony, or my brother will come. But my friend assumes that whatever I am saying is wrong, so he is going to negate the sentence.
Neither
It
you
means
nor
whatever I am saying, he believes that okay, you are wrong. It means he believes that
Neither my
Munavar will not come.
Yes, sir.
Negation of A means he assumes that I will not come,
and
and my brother will not come as well.
that's fine.
That's right. Okay, I assure him that any one of us will be attending your marriage ceremony.
Yes,
But
sir.
my friend assumes that okay, he is saying something which is not true. I believe that they will not come. It means he believes that neither I will come and nor my brother will come. Just simple. So, but doing this type of examples will not be good exercise. Rather, we should go to this.
Truth table.
And you can make these tables within 1 or 2 minutes.
Yes, sir.
It's not a big deal. Just you know the basic idea. Okay, what should we do in OR,
Yes, sir.
and what should we do in negation?
Negation.
What should we do in AND?
And.
Negation or AND.
And.
Okay, so this thing can be done by you as well in the similar way. The next thing is that what do we mean by tautology? And L-O-G-Y. And what do we mean by contradiction? Okay, an example? Any idea? What's a tautology? So it's a statement whose result is always true. It means you are given some sort of statement, its result means what we call the final column in the truth table must be true always. There is no any possibility for it to be false, then the statement is called to be tautology. For example, the statement is this: A and negation of A. What are the possibilities for A?
True or false?
I told you one thing, that you are going to put some possibilities. Whenever you are given only one statement A, whenever you are given A and B, then you have to put your possibilities for A and B. The rest of the things will be result of the first column. So negation of A would be true, false, and false becomes true. What is this? Negation of A or A. What do you do now?
Arrange tree.
Negation of A.
If this is or, it means you have to
True.
find out
Either.
any one of them, at least one of them must be true.
Yes, sir.
So what is the result?
Tautology. Tautology.
So when the result or output of a statement is always true, that's called tautology. An example,
Sun rises every day.
you have to give this statement with the connective or. So you have to give a statement with the connective or, and the statement is always true. Yes.
बंजर लगाना है.
Uh, it's true right now, but when it comes night, then it's going to be false. It should be true always. You can think of a statement A and its negation. It's not necessary you are going to think some other statements. You think a statement A and then the negation of statement A. The simple example is, I'll be going to the university today, or I will not be going. So someone will believe that okay, he is saying right, either he will be going or he will not be going, but I am not going to be certain. This is going to be called a diplomatic answer. Okay, either I am going to attend the party or I am not going to attend the party. Then someone asks, okay, what do you want? Tell us something specific, that whether you are coming or not. We don't want these double answers. So in those double answers, you will always assume that he is going to say something that is true. I am going to be attending your party, or I am not going to be attending your party. What is this? So this is always a true statement, and some person from other side will believe that okay, whether he is coming or not, we don't know. But whatever he is saying is totally correct. So this is called a tautology, and contradiction is the reverse. Can you tell me what is that? Contradiction is opposite of this.
This is always
Negation.
false.
The result is always
False.
false. Can you tell me example in this context?
Just have to
And,
end with
and,
ah.
and.
So this sign is just inverted. So result is always false. So A, negation of A, and A and negation of A. This is true, false, false, true. This is always false. Because in end we want both of these to be true.
Must be true.
So this is called a contradiction. And we'll be using this particular technique when we are going to prove different theorems.
So I am going to university and I am not going to university. So this is
How
the
is this
contradiction.
possible?
This is the contradiction.
This is a contradiction. So when you prove the theorems, you start with I am going to the university, and you prove a lengthy theorem, and you get result I am not going to the university. Then you will say that okay, the assumption that I will taken so far is wrong.
Yes.
Then you contradict it and you say that okay, our theorem is correct. This is what we call the method of contradiction to prove a theorem. So the next thing that is a bit important, and we are using it in mathematics and in our basic studies lots of times, and we call this implication. It means we have a statement, and that becomes the source for the next statement. Or we call, in other words, one statement implies another statement, or one thing implies another thing. And there are lots of real life examples for this. If it is raining, then we can imply something. We can deduce some results out of that. If it is raining, it implies that there must be clouds. There must be clouds. We can say that if x is odd, it means I am taking an odd number.
This is not
Then-
completely divisible by 2.
This is not completely divisible by 2, then x square is odd. So we can say lots of things. So we have a statement, when it implies something else, what does it mean? It means that we are taking a statement and we are deducing something out of that. Or that something is becoming the source for the next thing. We cannot deduce exactly, but that one information is becoming the source for the next information to be true or false or whatever it is. And we call this thing to be implication. And we write this as a statement A implies a statement B. Statement A implies a statement B. In other words, we write that if A,
Then B.
then B. We can write this thing in this way as well. We say that if statement A is whatever,
Hypothesis.
then statement B can be whatever it is. We say that if, let's say, x is odd, then x square is odd. So this statement is A and this statement is B. So this particular thing implies this thing. This is called implication. Now this thing is very much important when we are going to discuss the proofs of different theorems and corollaries or results. In this particular thing, the left hand side are the if statement.
Must be true.
Yes, it must be true. We are coming to that. But what is the name for this thing?
Hypothesis.
This is called hypothesis or assumption, and this is called your
Conclusion.
conclusion. So whenever you prove this thing, you always start with your hypothesis,
Yes, sir.
and then you reach at your conclusion. You start with the hypothesis, and you reach at the conclusion that you have so far. Now the main thing is that how can we construct the truth table for an implication? That's a bit logical and difficult thing.
Yes, sir.
So let us do this. So truth table for an implication. So let's say this is statement A and this is statement B. We are interested in the truth table for A implies B, and again you know very well these are the possibilities. So true and true, true and false, false and true, and false and false. And I say you one thing that if this thing is false,
Hypothesis must be true then. Yes, sir.
this thing is false. Am I right?
Yes.
I think I'm right, okay. And the rest of the things are?
False.
No, this thing is false and the rest of the things are true. What's the logic?
So if A is wrong, then
We are
B
not
is also
discussing
wrong.
this thing right now.
Conclusion must be true.
I say that the rest of the things, this is true and this, let me write, true. Let us discuss these three things, then we are coming to the last. Now why the first one is true, it's simple. It's simple. You take anything to be odd, a square is odd, but this is something what we call theorem. Let's come to something else. Take something that is true. It implies something that is true, then the whole result is going to be true. Any example? It's simple. 2 equals, let's say 1 plus 1. Is it true?
Yes.
It implies
1 plus 1 equal to 4.
Yes.
I'm squaring both sides.
Yes, sir.
This is true. This is true. Then this whole statement is true, and you believe this is true. Or in other words, I give you an element whose value is 5. I'm giving you this. And okay, you are going to square it and you say that okay, this is 25. Then this is true. This is true. You believe that this whole statement is true. There's no any problem with this. Can you tell me this thing? When both are false, but we call the whole implication to be true. Both are false, but we call the whole implication to be
True.
true. What's the example and why? In implications, you will not see that what is given to you. You will see the whole statement. I give you one information. I give you this information. I say you that okay, you have to believe that in some sort of another universe, 1 is equal to 2.
So might be 3 equal to 4.
No, you have to deduce something out of that. In that universe, 1 is equal to 2.
So 1 is square equal to 4.
1 square is equal to 4 means it implies, because what you are doing in that universe, the law of square also helps.
Yes, sir.
Law of squares is true.
3, yes, sir.
And one thing is that in not in some other universe, but in some of the schools that we are teaching so far, I think in Pathurk school, Sai Karim Jumani might remember, we were taking the value of pi to be 3 when we are teaching to the students. Then simply you will say that pi square is equal to 9. Both are false, but this whole thing is true. Because something that is given to you is already false, and you are going to deduce something from something false.
Yes, sir.
But the result is going to depend on that. So the whole implication is true. Whole implication is true. Yes.
True or false?
This whole is true.
True, yes.
This whole statement is true. The individual components might be false, but we are assuming them to be true in some sort of another universe that exists inside the Pathurk school. No, they are on the right track now because they have started Oxford. But I love their books that were taught before that. They were very nice books.
Without answers.
They were very nice books.
Without answer.
No, sir. Answer is not necessary. You can ask Sir Karim Jumani Sahab, answer is not necessary. The idea is necessary.
Anyway, small are also beautiful.
What about this? A false statement leads to a true statement. It means the whole implication is going to be true. False statement, but it leads to something that is true. Do you believe this thing is true in our universe? Minus 1 is equal to 1. It's not true. But you square both sides. Square both sides. Square of minus 1 is 1. Square of 1 is 1. Is this true?
Yes, sir.
So something false leads to something true. You will believe that this whole implication is true. This whole implication is true. So something false can lead to something true. Okay. But you have to see these three things. The rest one is true statement cannot lead to something that is false. A true statement cannot lead us to something that is false. That's the main problem. You will say that whole implication is false. And why is that so? And we are using this and we are doing this in our daily mathematics as well. We are using that implication, but unfortunately that is wrong. But we are using it. So let me give an example for this. The example is x square is equal to 25 implies x is equal to 5. You take a square root on both sides, the answer will be 5. What's wrong with that?
X is also equal to minus.
Yes. This thing is true, but this result is false. This must be 5 or minus 5. You are not supposed to put only one possibility. Because when you take a square root, it should be both positive as well as negative. So something true leads to something false. It means this whole implication is false. This whole implication is false. Can we take this table to a few next columns? Can you take the negation of A implies B? It's I think something very simple. You have this statement, you are going to negate this statement. True becomes false. False becomes true. True becomes false. True becomes false. Then you have to tell me the answer for this A and negation of B. What do you need for this? Do you have a statement A? Which is this. Do you have the statement negation of B?
B.
You don't have. You have B.
You have to
First you have to find out negation of
B.
B. So negation of B means you have to just invert this. True becomes
False.
false.
Because you.
False becomes true.
Because
False and true.
It's
Then
negation.
A and negation of B means take this and this is A. This is negation of B.
B.
What I have to take?
And.
And. For and what you need to do?
Both are true.
Both must be true.
You have to find both are true. False. This is true. This is true.
Are both may be false become true?
This is true.
Yes, sir.
Okay. And this is true. So in this case the result is
True.
and the remaining will be
False.
False.
Sir, last one line.
First or lie?
yes.
A is false and B is also false. Then what will be the result? A is false and B is false.
No, is this correct?
True or yes. Yes. Correct.
What is the relationship between these two? And this. What is the relationship between these two?
Equal.
Equivalent, I think.
Yes, sir.
Yes. False. True.
By equivalent, A implies B. When it is negated, you can see the truth table.
Truth table. Yes, sir.
And A and negation of B, you can see the truth table. Both are
Equivalent.
equal. So we say that these statements are equivalent, and we may give 2 or 3 lines like this. We'll be using this thing next time when we are coming back to this. Okay, so let's come to something that we need now. Is this okay?
Yes.
Yes.
Is it okay?
Yes, sir.
Yes.
We have to end this at Hasan sir, 2 or 145. Inverse of an implication,
Yes, sir. And converse.
and the second thing is going to be
Converse.
converse and then contrapositive. Converse and third thing is contrapositive of an implication. These 3 things hold a great importance when we are going to discuss these things. The first thing is that what is going to be the inverse of an implication. So in all the 3 cases we are taking this A implies B is our implication. Then what is going to be the converse or inverse of this implication?
B implies A.
Negation of B implies negation of B.
Negation of B,
Implies negation of B.
Who contrapositive?
that's contrapositive. So inverse is simply what you do. You write this thing Sam,
Just negate.
and you need to find out its inverse.
Just
Just negate both sides.
negate both sides. Right.
It means negation of A implies negation of B. So this is what we call the inverse of an implication. Now tell me some implication which is correct. Tell me some implication which is correct.
घड़ी लाइट यूज थी घड़ों पे नहीं दो डेफिनेशन उलट के उसको
Yes.
राइट
I am Sindhi or I live in Sindh
I live in
it implies that I live in Pakistan. This is my A implies B. Okay, what is going to be the
Negation.
inverse of this implication? Inverse means you negate both sides.
Yes, sir.
I do not live in Sindh. It implies I do not live in Pakistan. The implication is true or false, that is something else.
Yes, sir.
But we are considering how to find out the inverse. That is the first thing.
There is the fine.
So the first thing is that I live in Sindh, it implies I live in Pakistan. Whether it is true or false, I am not concerned about that right now.
Alright.
The first thing is that we should understand how to find out the inverse. So what is inverse? You negate both sentences. I do not live in Sindh, it implies I do not live in Pakistan. Now the question is, if this implication is correct, I live in Sindh, it implies I live in Pakistan. This is correct. Can you guarantee this statement to be true or false?
No.
You,
No, not sure.
I do not live in Sindh,
I don't
it
live in-
implies I do not live in Pakistan.
No,
It
false.
may possible.
It might be true,
Might be false.
false. How?
Maybe I live in Punjab and it's also in Pakistan.
Yes. He may be living.
Maybe I would live in Punjab,
Yes.
it implies I live in Pakistan.
Pakistan.
So there is no any possibility. So you are given an implication, its inverse might be true
Might
or
be.
false. We cannot guarantee. It can be true, it can be false. So it means you cannot readily believe something to be true or to be false, especially in the case of inverse of a statement. What is going to be the converse?
B implies A.
Yes.
The converse of A implies B would be
B implies
B
A.
implies.
Implies
It
A.
means in inverse what you do, negate both
Both.
and implication remains same. In converse you just flip the side so it becomes B implies A. This is going to be the converse of this statement. Okay. So now you have to think of this thing as well. If a statement is true, its converse is true or false.
Converse is also true. If implication is true, then converse is also true.
I live in Sindh, it implies I live in Pakistan.
I live
Converse may be true or
Its
false.
converse is I live in Pakistan, it implies I live in Sindh. It might be true or false. It might be true or false. You can take the example, if it is raining, there must be clouds.
Clouds.
It is true. It is true.
True.
If there are clouds,
Might be not.
it must be raining.
No, this is
It's
false.
not necessary. It's not necessary. So if a statement or implication is true, its converse may
Maybe
or may not be true.
Yes.
May or may not be true. In mathematics, this is something very general. In some statements, the converses are true, and in some statements, the converses are not true. So, on the fundamental level, mostly the statements are true. On the fundamental level, but when you go to some advanced level, they might be true or false. There is no guarantee for them. For example, you say x plus 2 equals 5 implies what?
Converse. 5 equals
3.
plus
X equal to 3.
No. X equals 3. And what is going to be the converse of this? X is equal to 3 implies
Yes.
x is equal to 3 implies x plus 2 equals 5. You can see this is true and this is true as well.
Yes.
Both are true. But there are the cases where these things are not true. Like you know very well, every convergent sequence is Cauchy and every Cauchy sequence is not convergent. There are Cauchy sequences. Basically every Cauchy sequence converges. But the main thing is the space in which you study the things. You always study that whether your Cauchy sequence converges to something, whether that something lies in that space or not. But Cauchy sequence always converges, and convergent sequence is always Cauchy. But when we say Cauchy sequence does not converge, we are always concerned what is the limit of that sequence, and does that limit lie in that set or not? That is the problem. If that limit does not lie in that set, we say that the Cauchy sequence does not converge. It converges basically, but it does not converge in that space. That's the problem.
With respect to that set.
Yes, with respect to the space that we are studying, like we are taking rational numbers, then every Cauchy sequence might not converge in rational numbers. It converges, but it converges in real numbers, not in the set of rational numbers. Okay, we'll be doing this thing later on. Okay, what is the contrapositive? This is going to be a bit interesting.
Negation of B implies negation of A.
Yes. So in this one you keep the order same, but you negate both.
Negate both.
In this one you change their order. In contrapositive, first you change their order. Means A implies B becomes B implies A, then you negate both. It means negation of B implies negation of A. And the beautiful thing about this thing is that when this is true, this is also true, and when this is true, this is also true. This is something very good. A implies B, for example, I will live in Sindh, it implies I live in Pakistan. What is going to be the contrapositive of this?
If I do not live in Pakistan, I do not live in
If I do not live in Pakistan, it simply implies that I do not live in Sindh.
Sindh.
Because if I'm not inside Pakistan, how can I be inside the part of a Pakistan? It's not possible.
Yes.
So when this is true, then this thing is also true. Sometimes we apply this particular method to prove different results. We call this the method of contrapositive. Because proving this thing might be a bit difficult, then we prove this thing. If we prove this thing, this is true, obviously that thing is true as well. If that thing is true, means this thing is true as well. So these are three different things which we'll be applying whenever we are going to discuss the proofs of different theorems and results.